Our learning objective for this video is that to work on the hypothesis test for the second category. So for the second category means that our parameter of interest is mu, right? But we don't know the variance of the population. So we are interested to find out the amount of the mean, to do like statistics on the amount of the mean for the population. But sigma 2 is unknown. So that's my parameter of interest in the second category. So with the hypothesis test, we said that we have 8 steps. The first step is that, okay, the parameter of interest. The second one is that state the null hypothesis, specify your alternative hypothesis. So it's like that here is that when you want to see that if you have the one-sided, two-sided, if you have one-sided, is that upper tailed or the lower tailed. Then you want to choose your alpha, appropriate test statistics, set the rejection region, computation, and conclusion. In the previous video, when we were working on the category number 1, so we worked on all of these ones. I'm going to go through the parts that is different. The first thing that is different is the parameter of interest, right? So the parameter of interest here is mu, but we don't know the variance of the population. So the next thing that we want to work on that here is that, okay, so that was the, let's say this is my step 1. Step 2 is that my null hypothesis, and I would say for my null hypothesis, my mu is equal to mu null, right? So whatever comes from the specification. And then I have my alternative hypothesis, and based on my alternative hypothesis, that to see if it's the one-sided or two-sided, I would have my rejection region here. So let's say and here I have my alternative hypothesis. So with the alternative hypothesis, I would have it as a mu not equal to mu null, as a two-sided, right? So this is the two-sided. Or I would say mu greater than mu null, or mu less than mu null, and these are the one-sided. So that's my alternative hypothesis. Then I'm going to choose my alpha. Choosing alpha is like that based on the different confidence interval that you're working on. We can choose different alphas. So we would say that alpha is like 5%. So we're going to talk about the alpha here. Number 5 is the appropriate test statistic. So the test statistic here is different. So number 5, we would, for the test statistic, we are working with T. So instead of Z null that we had for the first category, for the second category, so we would say T null. That would be my test statistics. And for this one, T null is equal to x bar minus mu divided by, on the denominator, I would have S, because I don't know the sigma, I don't know the standard deviation of the population. So I would need to find out the standard deviation of the sample. So it's going to be S over the square root of n. It's very similar to the test statistic that we had for the first category. For the first category, it was x bar minus mu divided by sigma over a square root of n. So that's the test statistics that we have here for the T null. And then the next one is the state the rejection region. So for the rejection region here, because we are working with the T null, it's going to be a little different than these ones. So here, what's going to happen up to here, up to step 6, is that you're going to choose your alpha, and then you would need to find out from the table, you would need to find out the T value for it. but with the t value we have alpha or half of the alpha. It depends if it's one-sided or two-sided, but we need to know the degree of freedom as well when we are reading from the table. So it's going to be t alpha n minus 1. N minus 1 is my degree of freedom. And then here for the test statistic, instead of z0, which was for the first category, we would have, I'm going to find out my t0, right? So then we said that for the rejection region, in fact, we want to compare this t at the t for the alpha or half of the alpha with this t0. So when I'm looking at here, and let's say we are working with the two-sided, what's going to happen is that I have the t at half of the alpha, n minus 1, and again t at half of the alpha, n minus 1, right? So I will have these ones. I'm gonna find out the t for the half of the alpha of n minus 1, which is related to this half of the alpha and this half of the alpha, right? And then I'm gonna compare it with the t0 that I have. So with the rejection, look at here, these are the rejection region, right? So what I'm gonna say, I would say if I have two-sided, if my t null, this one, so for the rejection area, which is the step 6, so I would say if t null is greater than this number, right? So it would be greater than t half of the alpha n minus 1, or if my t null is less than, if it's here, less than minus t half of the alpha n minus 1. Right? So if I'm in these two region, I'm in the rejection region, rejection area. But this is for the two-sided. If I had one-sided, instead of this half of the alpha, you would put just alpha. Right? So this is your rejection, and then rejection area, and then you have your computation. So for the computation area part, what you would need to do? You would need to find out your x bar, find out your s and your n for your sample size, right? And then find out the amount of the t null, to say that, okay, so this is my t null, and in part A, 8, it's like that you will make a conclusion by seeing that if you are in the rejection area, rejection region or not. So for the A, you're going to make your conclusion. The next category, so these ones, we worked on the second category, which the parameter of interest was mu, and we didn't know the sigma of the variance. I'm going to work on an example in another video, and then the next category would be the time that we are looking for the parameter of interest is going to be variance. Before going to learn about the case that the parameter of interest is variance, I would recommend that you would go and look at the practice problem of category number 2, and then go to the next category to learn more about these hypothesis tests.